in part 2 of the place value system series that we got going on. Excuse me. In part 2, we talked about decimals and kind of how they work in the scheme of the place value system. What we're going to be talking about in part 3 is writing decimals. When it comes to writing decimals, one of the most important things to kind of know off the bat is that any number that is a decimal is going to have, excuse me, a decimal point, which is going to look, let me try to draw another little dot. It's going to be like a dot. For example, we have 1.75, or we could have point. Let's see if I can. Let me try something out there. Let me try something out. Let's see how this one works. That's a little better. We could have 1.75, or we could have 0.23 or something like that. But every number that's a decimal, we could have 3,000.1. You know, any number that is a decimal is going to have a decimal point. And a decimal point is basically a plus sign. It's basically a plus sign. It doesn't mean 0. It doesn't mean 1. It means and. So, for example, 1.75. What that means is we got 1 and 0.7. Or matter of fact, no. We're going to do this. We got 1 and 75 over 100. That's what that means. And another way to say that is we got 1 plus 75 over 100. So, excuse me. So every number that is a decimal is going to have a decimal point. And the decimal point just simply means and or plus. So that's the first thing that you're going to want to know about writing decimals. But let's go with an example. Let's do, 21.97. Excuse me. So, obviously we got that, we had that written, but what we're going to do in this video is use expanded notation to understand a little bit more about writing decimals and what's going on underneath the hood, you know what I'm saying? What's going on behind the scenes. So, 21.97. In the previous 2 videos in the place value system series, we talked about whole numbers and kind of why people started using the decimal system, the place value system, how you kind of read it, how it works, where numbers go, and stuff like that. And so we already talked about the positive side. Excuse me, not the positive side, but we talked about everything to the left of the decimal point. So let's deal with those 2 first. So we got 2 groups of 10. So that's going to be 2 times 10. And what else we got? We got 1 group of 1. So that's 1 times 1. So that's going to be 20 plus 1. That's easy. Now, excuse me. The same thing applies with these decimal points that we have. This 0.97, what does that mean? What does that represent? And kind of how do we get there? Let's use the expanded notation to kind of, again, to kind of explain that. So the same as with this 1 right here, this 1 over 10 is saying that whatever number we got up here is this many groups of 1 over 10. So we got 9 groups of 1 over 10. So we can just multiply that like this. So that's 9 over 1. 9 groups, anything over 1 is just the number on top. 9 groups of 1 over 10. Instead of writing, 1 over 10 9 times. This is going to give us, when we multiply straight across, 9 over 10. So we're going to add that in there. Let me change this color up a little bit. And then plus, so we got 20 plus 1 plus 9 over 10 plus, what we got up here? We got 7. We got 7, because this is the 100ths place. We got 7 groups of 1 over 100. So that's 7 over 1 times 1 over 100. And that's going to be, when we multiply across, 7 over 100. So now, let's see, now we can't zoom out neither. So now, let's look at all that we got right here. Whoa. We'll move it right here for right now. So we got 20. I'm write it over here. We got 20 plus 1. And these are non-decimal numbers. But then we got the decimal point, right? Hold up, the thing tweaking. But then we got the decimal point. So we got 20 plus 1. And remember what I said about the decimal point. It just means and, or it means plus. So we do the same thing on this side that we did on this side. So 20 plus 1 plus 9 groups of 1 over 10. And that's going to be, again, 9 over 10 plus 7 over 100. Once we add all this together, this is going to give us what the value is. Outside of just the notation. Now, I know we wrote 21.97 down, but if we want to think about that in terms of tally marks or just a raw value or a raw quantity, once we add these, we'll have that quantity. Before we go through and add this, 20 plus 1, that's going to be simple. That's going to be 21. But before we add these two fractions, we got to give them the same denominator first. So let's do that down here. So we got 9 over 10 plus 7 over 100. These are not the same, so we're going to multiply these two denominators. It's going to give us 1,000 for the denominator. So we started with 10 on this one, and we ended with 1,000, so that's times 100 down here. Do the same thing up here. That don't look like 100, so let me. Cool, so 100 times 10 is 1,000, 100 times 9 is going to be 900. And for this one, we started with 100 on the bottom, and we ended with 1,000, so that's times 10. We scale that by 10. So we do the same thing to the numerator. So that's going to be 70. So after we add these, we get 970 over 1,000. And we can cross out, divide both of that by 10, or 100 rather. 10 or 100, 1 or 2. That's going to give us 97 over 100. We could do it one more time, but we're not going to do that. So now we got 21 plus 97 over 100. Now again, instead of using this type of notation, we're going to use the decimal point that we use. So like I said earlier, this plus sign really means, can be used as a decimal point. And instead of writing 97 over 100, we can write 9/10 and 700s. Get rid of this. Let's say we had something like point. Let's say we had 0.36. Again, so what are we saying here? We got 3 groups of 1/10. That's what we're saying. Now, we're writing it in a way that saves us time and save us space, but that's the quantity that we're talking about. We're talking about 3 groups of 1/10 and 6 groups of 1/100. And remember, there's nothing special about the number 10. Don't get married to the number 10. These numbers, they can be anything. This could be 7, 49, and so forth. So don't get married to the values in the place. We just chose those because they're convenient. Then we got 10 fingers and 10 toes. But so for this example, we got 3 groups of 1/10 and 6 groups of 1/100. So let's scroll down. We got 3 groups of 1/10, which is going to be 3/10, and we got 6 groups of 1/100, which is going to be 6/100. Excuse me. So we have to add these two together. But before we can add these 2 fractions, we have to make sure that they have the same denominator. So let's do that. Three over 10 plus 6/100. So these 2 are not the same denominator, so we multiplied the denominators. It's going to give us 1,000 for both denominators, for both fractions. For this one, we started with 10 and we ended with 1,000. That's times 100. So we do that on the top as well. Excuse me. 300. For this one, started with 100, ended with 1,000 as the denominator. That's times 10. It's going to be 60. So now we can add these 2 fractions because they have the same denominator. And when we do, it's going to be 360 over 1,000. We can take away a 0 from both of those numbers, and that's going to give us 3,600s. And that's exactly what our decimal is representing. Let's put that back. 3,600s.